Hello student, I am Dr. J. Today I am going to start new chapter, that is the periodic table. This is the very important chapter, and chemical properties, physical properties of the elements mainly depends on this periodic table, and what are the properties of the elements. Mainly it is discussed on their arrangement in periodic table. Many electrons, many elements was found. Then how it should be arranged so that it can be studied systematically. Then elements were arranged in a proper way so that these elements can be studied, and for that purpose, from the beginning, when many elements was discovered, then problem was how to study these elements. Then so many scientists tried to arrange it in a proper way, property of this according to their chemical and physical properties. Then now I am going here to discuss this some arrangement which was tried by chemists. Four chemists, total five chemists tried. Finally fifth chemist, fourth and fifth were successful. Then this three chemists in the beginning, what they told, actually initiation is also important. That time, in the beginning, if anybody tries, then their work you can't ignore. Then here also three scientists, they have tried their level best to arrange all elements in a proper way. Then who were that scientists or what they did, that I am telling you, because sometimes in general competition these questions are asked. Who was the scientist who did first time, in which year, like UPSC examination, or in general any competition, medical engineering also they are asking. Then some question, theoretical question is asked from the beginning of periodic table chapter. That's why I am going to discuss these things. Just listen carefully. Classification of elements into groups and development of periodic law and periodic table are the consequences of systematizing the knowledge gained by a number of scientists through their observation and experiments. The German chemist John Deverner in early 1800, name you just keep in mind, Doverner, John Doverner is a name. In early 1800 was the first to consider the idea of trend among properties of elements. Trend, T-R-E-N-D-S, trend among what are the trends of properties of elements. First time in 1800, this John Doverner he just began to think in that way. Was first to consider the idea of trends among properties of elements. By 1829, he noted a similarity among the physical and chemical properties of several groups of 3 elements. Here you can see he found groups of 3 elements, only 3 elements, that is called triads. That he found that in triads, Triads, triads means 3. In the beginning he make a group of 3 elements only, that is called triads, and he found some similarities there. In each case he noticed that middle elements out of 3, first, second, third, then second was their property was between the first and second. In each case he noticed that the middle element of each of the triads had an atomic weight about halfway between the atomic weights of other 2. First and second is there, then middle was just in between of first and second. At a particularly atomic weight, the atomic weights, he was giving focus on that atomic weight. In each case he noticed that middle element of each of the triads had an atomic weight about halfway between the atomic weight of other 2. Also, the properties of the middle elements were in between those of the others 2 members. Since Dauvernier's relationship, which is called law of triads, seems to work only for few elements, it was dismissed as coincidence. It was dismissed because it was working only for few elements. Now, second scientist who came after that, who take an attempt, I am talking about that. The next reported attempts to classify elements was made by French geologist. His name was A.E.B. De Broglie, like that way, D.E. Chan-Cotois. His name was Chan-Cotois. In 1862, he has taken attempt. Chan-Cotois has taken attempt in 1862. What he told? He arranged the you can say elements in order of increasing atomic weight and made a cylindrical table of elements to display the periodic occurrence of properties. Again I am telling, then this Chan-Cotois in 1862, what he did, he arranged elements in order of increasing atomic weight and made a cylindrical table of elements to display the periodic recurrence of properties. Property was repeating. This attempt was also, you can say, didn't get much attention. This also did not attract much attention. Means it was also dismissed. Now third English chemist John Alexander Newlands. In 1865, see, main research took place that it is only in this period, 19th century. 19th century main research took place. Okay, keep in mind. Means it has started with 1800 somethings. It has started in the beginning only, beginning of 18th and 19th century. More research took place. Then now I am talking about what this Alexander Newland told, third chemist, in 1865. What he told? He propounded the law of octave. But all scientists has given some idea. Then this has given this Alexander Newland in 1865 propounded the law of octave. Means he considered a group of 8 elements. 8 elements, octave. Octave means 8. Law of octave. He arranged the elements in increasing order of their atomic weights. What previous I told you, he also tried, but it failed. Now this Newland also, he arranged the elements in increasing order of their atomic weight. What last chemist did, he also did same way. And when he arranged the elements in increasing order of their atomic weight, then he noted that every eighth element had properties similar to the first element. The relationship was just like every 8 note that resembles the first in octave of music. In music also it happens. It will repeat. First and 8. Like that way element was also repeating. Every 8 was repeating with again next first. 1 to 8, again 1 to 8, again 1 to 8. Then after the 8, next one was there. Then it was repeating with that. Again 1 to 8, again 1 to 8, again this property was, there was similarity in this group. Then he arranged in that way. That is called law of octave. Newland's law of octave seemed to be true. Correct. Seems to be true only, but it was true only for elements up to calcium, means 20. Atomic number 20, now at present, it was found correct only up to calcium. Then it also has not worked. It also stopped. Idea was stopped. But octet, law of octet, that idea was continued. But it was correct only up to calcium. Although his idea was not widely accepted at that time, but he for his work was later awarded Davy Medal. One award is there given by the Royal Society, London. I will tell you later on about these things. Okay, Royal Society, what is this? I will tell you later on. Royal Society is London. It is very old, these things, association. Or you can tell these things that for the chemistry, it is a very old association, only you can tell Association of Chemists. Okay, now I will tell you details any other time. The periodic law, as we know today, owes its development. Who have developed now present? The periodic law, as we know it today, owes its development to the Russian chemist Mendeleev. This is the person, Mendeleev. 90% he has contribution. 90%. His full name is Dmitry Mendeleev. But question is asked, then they will write other name also. But here his full name is Dmitri, D-M-I-T-R-A, Dmitri Mendeleev. And one more chemist, German chemist, Lothar Meyer, M-E-Y-E-R, Meyer. Both, actually, both has developed a periodic table. The periodic law, as we know it today, owes its development to the Russian chemist Dmitri Mendeleev and the German chemist Lothar Meyer, working independently. Both the chemists in 1869 proposed, both together in 1869, just to date remember, in 1869 proposed that an arranging elements in the increasing order of their atomic weights, similarities appear in physical and chemical properties at regular intervals. This is the actually law, periodic law given by them. He proposed that on arranging elements in the increasing order of their atomic weights, similarities appear in physical and chemical properties at regular intervals. After that, now what happened? Lothar Meyer observed a change in length of that repeating pattern. Lothar Meyer observed a change in length of that repeating pattern. By 1868, Lothar Meyer had developed a table of the elements that closely resembles the modern periodic table. Now, what nowadays is there, that is the modern periodic table, but it will match with 90%. It will match with the, you can say, previous Mendeleev. After the Mendeleev, one more scientist came. I will tell you, that is the final. That is called modern. But this both developed one periodic table. In that, some modification took place. Now, first listen about Mendeleev only. Then however, his work was, actually he also tried to make a separate this Meyer, but he didn't get success. However, his work was not published after the work of Dmitri Mendeleev. Mendeleev, what he did, he also was trying separate, and he got success. Mendeleev, the scientist who is generally credited with development of the modern periodic table. He has role in that modern periodic table, not 100%, but only on his law modification was done. But what was the, you can say, this his periodic table, periodic law, Mendeleev periodic law, I am telling you, this is the semi-final, you can tell. Final is done by modern, that is the modern periodic table, and I will tell the name of the chemist also. But now, what Mendeleev told, what is the actually his periodic law, that I am telling you. That Mendeleev, who was responsible for publishing the periodic law for the first time that he published a periodic law. I am talking about the law, periodic law, for the first time. It states that, I am telling you a statement. What was the statement? A statement of the law. The properties of the elements are a periodic function of their atomic weight. This is the law given by Mendeleev. This is the law given by the Mendeleev, a statement given by the Mendeleev. This is called periodic law. The properties of the, I am telling you, properties of the elements are a periodic function of their atomic weight. He is considering atomic weight. But now what happened later on? Mendeleev arranged elements in what Mendeleev did, I am briefing you. Mendeleev arranged elements in a horizontal row and vertical columns. Just to keep in mind. Mendeleev arranged elements in horizontal rows and vertical columns. What now in modern periodic table you are seeing in that way, horizontal rows and vertical columns of a table in order of their increasing atomic weight. In such a way that the elements with similar properties occupied the same vertical column or groups. Mendeleev's system of classifying element was more elaborated than that of Mayer. Mayer was unsuccessful actually. People given priority for Mendeleev. Lothar Mayer says that was not accepted, but Mendeleev was better. Mendeleev's system of classifying element was more elaborate than that of Lothar Mayer's. He fully recognized the significance of periodicity and used broader range of physical and chemical properties to classify the elements. Now, after that what happened? After that, now see Mendeleev, he realized actually this Mendeleev, he also found some weakness in his periodic table. Himself he realized. What he realized? Mendeleev you can say, relied on the similarities in the empirical formula and properties of the compound formed by the elements. He relied, Mendeleev relied on the similarities in the empirical formula and properties of the compounds formed by the elements. Then what he realized, I am telling now. He realized that some of the elements did not fit in with his scheme of classification if the order of atomic weight was strictly followed. See, he realized his weakness. He realized that some of the elements did not fit in with his scheme of classification if the order of atomic weight was strictly followed. He ignored the order of atomic weight. He himself ignored the, you can say this, he ignored the order of atomic weight. He got dot. He ignored the order of atomic weights, thinking that the atomic measurements must be incorrect, and placed the elements with similar properties together. He placed the elements, ignoring the atomic weight, placed the elements with similar properties together. Okay. Now, after that, you can see, actually, he left several gaps in periodic table. In his periodic table, he left several gaps in the table. Keeping in mind, because that time it was not discovered, it was undiscovered. But for that he left some gap. He proposed that in his periodic table proposal was there. He proposed that some of the elements were still undiscovered and therefore left several gaps in the table. For example, I am telling you, both gallium and germanium were unknown that time. Mendeleev published his periodic table. Finally, he published. He left the gap under, you can say, aluminum and a gap under silicon. He left the gap under aluminum. At present we are knowing that time gap was there. He left the gap under aluminum and a gap under silicon, and is called these element they are called as a Ekka aluminum and Ekka silicon. Question will be asked. Ekka aluminum and Ekka silicon. Mendeleev predicted not only the existence of gallium and germanium. Actually, Mendeleev predicted about these two elements. Mendeleev predicted not only the existence of gallium and germanium, but also described some of their general physical properties. Okay. Now, this I have discussed all the things, and this Mendeleev, the one thing more, the boldness of Mendeleev's, you can say, quantitative prediction. The boldness of Mendeleev's quantitative predictions and their eventual success made him and his periodic table famous. This Mendeleev's actually periodic table became famous, and Mendeleev's periodic table published in 1905. It is accepted, but now in this modification took place. The Mendeleev this things periodic table published in 1905. That table just I will give you in the these things in video, that periodic table what Mendeleev made. I will give you. Today I am stopping only here, and next class final, you can say, this things periodic table, modern periodic table, which is at present that I will discuss. Okay, thank you.